All right, let's go ahead with lesson 9.3 in your book, page 489, factoring trinomials in the form of x squared plus bx plus c. All right, well, first of all, let's review just multiplication again, and let's notice some things as we go. Let's say I have x plus 2 times x plus 3. I use my arrows and I multiply it out, and I get that x squared from the first terms. The outer terms are x3x, the inner terms are 2x, and the last term is 6. I combine those. I notice that the x's are like terms, so I really combine them. X squared is plus 3 plus 2x, okay, which gives me x squared plus 5x plus 6. Now let's take a look at x, just the factoring using variables instead of numbers. If I have x plus n times x plus n, I really just multiply that out. I get x squared from my first terms. My inner two terms, or my inner term and my outer term added together are n plus m times x. And the final term, the last term, is always m times n. Okay? So if you were to look at this in the form of x squared plus bx plus c, you'll notice that b would take the place of n plus m, or m plus n, here, and c takes the place of m times n. So since you know that's the pattern, we then now can start building some equations. So let's take a look at it here. Okay? Let's look at it very simply, restate it. X squared plus bx plus c is equal to x plus m times x plus n if m plus n is equal to b, the coefficient of the middle term, and m times n is equal to c, the coefficient, or the last term. Now let's look at this as an example. We use the example we used up above. X squared plus 5x plus 6 is equal to x plus 2, x times x plus 3. Well, let's take a look. Are our m and our n values, 2 and 3, are they going to be, when added up, do they equal our b value, which is 5? Well, 2 plus 3 equals 5. b is 5. That is correct. How about when I take m and n, 2 times 3 equals 6. Is that equal to c? Come over here, and yes, it is, c. So that's just a quick way of looking at it. And that's the pattern we're going to follow. We're going to look for an addition of two numbers that add up to the middle term but multiply to the third term, coefficient of the middle term. Okay? We have example 1. Example 1, what happens in the example 1 when I have the following? I have a equation or expression in this format: x squared plus bx plus c. And then in this case, I want to know that b and c are both positive. When they're both positive answers, b is positive and c is positive, what do we do? Well, how do we factor them? Well, let's just use an example. And example number 1 is this: x squared plus 6x plus 8. Well, I'm going to show you how to do it. You're going to, when multiplied together, two numbers that equal 8, and then add up to that. And how do you do that? Well, we're going to write the third number, the c value, in a factor table. But I'm going to add in it a third column, which I'm going to call the summation table, or column, or the plus column. So now I'm going to do my factors. Well, what is my factors of 8? Well, 1 and 8 equals 8. 1 times 8 equals 8. If 1 times 8 equals 8, well, what do they add up to? Well, they add up to 9. Is that number the b value, or the coefficient of the x, the second term? No, it isn't. So let's go on. Let's say 2 and 4. 2 and 4 added together give me 6. Is 6 the coefficient of that? Yes, it is. So that is the correct pair of numbers that I want to use. And when I say that, find that correct pair, I can then just say that this is factored out to x plus 2 and x plus 4. And that is the factoring of that problem. So, okay, let's restart here with number 2. Example number 2, we'll get x squared plus bx plus c, where b is a negative number and c is a positive number. Here's our example. X squared minus 10x plus 16. So b is a negative 10 and c is a positive 16. So we're going to make our little chart, our little factoring table where we want a positive 16. But since we know the addition of those two numbers have to add up to a negative number, and they both have to multiply to be a positive number, we're both going to be negative numbers. So we're going to start with negative 1 and negative 16. When multiplied together, that gives me positive 16. Added together gives me negative 17. So that's not the pair I'm looking for. Okay? So let's try negative 2 and negative 8. Well, negative 2 and negative 8, when added together, give me negative 10. Uh-oh, there it is. Negative 10, negative 10. So that tells me that 2 and 8 are negative, are my two numbers. So this is equal to x minus 2 times x minus 8. Okay, example number 3, we got x squared plus bx plus c again, but this time we're worried about when b is positive and c is negative. So our example here is x squared plus x minus 12. So b being not, there's no coefficient there, it really means there's a 1 there. So b is a positive 1 and c is a negative 12. Well, when I make my chart here, I know that I want to multiply up two numbers that equal negative 12, and when they add together, they want to add to a positive 1. All right. Well, when I multiply two numbers together to negative 12, I got negative 1 and 12. They add together to be 11. That's not what I'm looking for, so let's try 1 and negative 12. That's negative 11 when they add together. That's still not what I'm looking for. Let's try negative 2 and 6. Negative 2 times 6 added together gives me positive 4. That's not what I'm looking for. So let's try 2 and negative 6. That gives me negative 4. That's not 1, the 1 I'm looking for. Alright, so let's continue on. Let's try negative 3 and 4. Negative 3 and 4 adds up to be positive 1. Well, that is what I'm looking for. There's my positive 1. Even though it's not there, that's really a 1. So that matches. So this is my two factors. Numbers that go into my factors. X minus 3 and x plus 4. So see the negative 3 and the 4, negative 3 and the 4. And that is my factored answer. All right, let's look at example 4. In example 4, we have, once again, our format of our equation is x squared plus b plus c. And in this example, we're going to deal with a negative b and a negative c. All right, so here's my example. X squared minus 7x minus 18. So we know that our multiplication factor table is going to try and worry about minus 18. When you add them together, we're going to try and get to negative 7. So let's start off with negative 1 times 18. Negative 1 times 18 gives me my negative 18, but it adds up to 17. Well, let's try the opposite of that. 1 and negative 18, that adds up to negative 17. So I still haven't found what I'm looking for. Let's extend this down a little bit. Let's try negative 2 and 9. Negative 2 and 9 adds up to 7. Well, that's close, but it's not negative 7. It's just 7, so that's not right. But that tells me that the opposite signs of that two factors is probably going to come up right, and there it is, -7, -7. So 2 and -9 are my numbers, x plus 2 and x minus 9. Okay, now let's take a look at example 5. In example 5, what's going on? In example 5, they say sometimes you have an equation that doesn't quite look right, and they want you to solve the equation. Not just factor it, but actually solve it. So you're going to use the concept of factoring the equation, and then you're going to probably use the zero product theorem. And if you remember, that is, you set the two factors equal to 0 and solve for both, and then you have two answers. And let's take a look at an example of that. Let's say we have x squared plus 5x equals 6. Well, right away I can't do anything with that because it's not in the standard format that I want, x squared plus bx plus c. So I'm going to subtract 6 from each side, and that leaves me with x squared plus 5x minus 6 equals 0. All right, now I can see the potential here. So I'm going to go ahead and just do it right here. I need to factor to get to -6, but when I add it, it needs to be +5. So -1 times 6 is added together is +5. And right off the bat, I found an answer. Okay? So I know that this 5 is right because it matches this +5 right here. So I now know that I can say that this factors to x minus 1 times x plus 6 equals 0. And once you have that, I can use the zero product theorem to set each half equal to 0. So x minus 1 is equal to 0, and x plus 6 is equal to 0. X is equal to 1. I added 1 to both sides. Over here, I'm going to subtract 6 from both sides. X equals -6. And so now my answer set is 1 and -6. So let's look at the last example, example 5. Or example 6, excuse me. Example 6 goes like this. It's kind of a long, convoluted story, but basically I have a picture, and I want to expand that picture by the same amount out and up. So we're going to call that x. So I'm going to end up with a new picture that big, but I want my new area of my picture to be twice as big as the old area. Okay? So I know that this used to be 8 and 12 is the old. So basically, from that logic, I have to figure out what is my equation for x. How big do I have to figure it out? How big do I have to make x in order to double the size of the picture? Well, let's take a look. At first, I can say to myself that the x plus 12 times x plus 8, notice that's my new width and height, okay, is going to be equal to my old area, which was 8 times 12, but I want this new area to be double that, so 2 times 8 times 12. All right, does everybody see that there now? So I've got my new width and my new height is equal to my new area. And I just have to solve for x. So doing so, I'm going to multiply it out. I get x squared plus 12x plus 8x plus 96 is equal to, and this is 192. 2 times 8 times 12 is 192. And now I notice that I have like terms, so I'm going to go x squared plus 20x plus 96 equals 192. Now I'm going to subtract 192 from both sides. X squared plus 20x minus 96 equals 0. Now I need to factor that. So I'm going to come over here and do a table. I need to find negative 96 and needs to add up to positive 20. So that's the goal I'm looking for, positive 20. So let's try negative 1 and 96. Well, that obviously is 95 when they add together, so that's not right. So let's try the opposite. 1 and negative 96. That's negative 95. So that's not right. Excuse me, there you go. That's not right yet. So let's try negative 2 and 48. And that's a 46. Well, that's not 20. Remember, we're looking for 20. So we try the opposite of that, 2 and negative 48. Well, that's negative 46. So let's try 3, negative 3 and 32. Well, that's 29. Let's try 3 and negative 32. That's negative 29. Let's try negative 4 and 24. And that gives me 20. Oh, there it is. There's the 20 that we were looking for. So that means these two are my factors and go into my factor. So x minus 4 times x plus 24 equals 0. Then I set each side equal to 0 using the zero product theorem. Add 4 and add 4. X is equal to 4. Over here, x is equal to negative 24. So my solution set is 4 comma negative 24. That's my two possible solutions. However, if you remember, my original problem was how much distance do I have to add to it? I can't have a negative distance. So my final answer is 4. And I go back and I look at the problem, and I didn't write that up here, but these are centimeters. So 4 centimeters is my final answer.